Hi, it's Mrs. Huntley. This is Module 4, Lesson 2. You should be on page 7 of your workbook. Lesson 2, Writing Equations Using Symbols. Your essential question today, how do you determine the difference between a linear and a nonlinear equation? Throughout this part of the module, we're going to be encountering, words that we're going to be turning into number sentences, and we want to talk about the difference between an expression and an equation real quick. So in mathematics, what is an expression? An expression is a number sentence that does not have an equal sign, or it's a group of terms on one side of the equal sign. You might have guessed by now that an equation is a number sentence with an equal sign. In the word equation, you have the first part of the word equal, so hopefully that will help you remember which one has the equal sign and which one does not. Now the equal sign divides the equation into two equal parts, the left side of the equation and the right side of the equation. On each side of that equal sign, we can say that there is an expression. They're just separated by that equal sign, and the whole thing together is an equation. Let's look down below. We've got a chart of a bunch of, are these expressions or equations? Well, if you read here, you'll see that they're expressions, but you can also tell because there's no equal sign in any of these expressions. So they contain both linear and nonlinear expressions, and they're asking us to sort them into groups and be prepared to explain what the difference is about the two groups. What I'm going to do is I'm going to circle all of the linear expressions, and I want you to take a look at them and see if you can figure out the difference between the linear and the nonlinear. Okay, those are all linear expressions. The ones that are not circled are non-linear expressions. Can you tell the difference between them? Can you figure out what the difference is between them? Okay, hopefully you're recognizing that 5x plus 3, 11 times the quantity, x plus 2, negative 8x plus 7/9 minus 3, 31/100 x plus 7 minus 4 2/10 x. None of these, okay, I said 4 of them. Let me say one of the ones that are nonlinear. 4x to the second power minus 9. 9 minus x to the second power. Notice I'm saying to the second power, or they're raised to an exponent. Now you might be tempted to say that any expression without an exponent is linear. However, if we remember back to our exponent unit, which was the first thing we did this year, we know that an exponent of 0 will give us a quantity of 1. And we also know that generally speaking, we don't write 1 as an exponent. Isn't 11 to the first power technically 11? It's 11 times itself one time, which is going to be 11. So we generally don't write an exponent of 1. So a better way of defining nonlinear or linear expressions with an exponent other than 0 or 1 are nonlinear, which again would say expressions that have an exponent of 0 or 1 are linear. But again, because we generally don't write an exponent of 1, we're probably going to look for the expressions, and we're going to say any expression that doesn't have an exponent is going to be linear. So if you have to take a minute and write down these notes, you may go ahead and do that. Expressions with an exponent other than 0 or 1 are nonlinear. Remember from the first module this year, we learned anything raised to the 0 power is equal to 1. Also remember, we generally don't write an exponent of 1. We could, on all of these expressions, write an exponent of 1. The reason I'm cautioning you of that is if you see something that has an exponent of 0 or an exponent of 1, it is, in fact, linear. Let's move on to page 8. So they're asking us now, how can we distinguish between linear and nonlinear equations? Hopefully you can put this in your own words because I'm using the book definition. You don't have to copy down the exact definition. Put it in your own words. Make it easier for yourself. Linear, sums of constants and products of constants and variables raised to a power of 0 or 1. So again, if you're looking at it and it doesn't have an exponent, or if it has an exponent of 0 or an exponent of positive 1, you can say it's linear. Nonlinear if we've got numbers that are raised to anything other than 0 or 1, it's going to be a nonlinear expression. Let's look at example 1. A linear expression in x is an expression where each term is either a constant or a product of a constant and x. For example, the expression 57 minus x is a linear expression. However, the expression 2x to the second power plus 9x plus 5 is not a linear expression. Why? Hopefully right now you're writing down the answer before I even drag it over. Because it has an exponent of 2. This exponent of 2 right here makes it nonlinear. Now, there were some words in there where we're talking about constants and variable terms and some other things that maybe you haven't used in a while. So let's go ahead and write some vocabulary down here. Terms are things in an expression that are separated by the plus or minus signs, the addition or subtraction signs, not negative signs, but addition or subtraction signs separate the terms. So in this one up here, 4 plus 3x to the 5th power, we have two terms here separated by this plus sign in between. Constant terms do not have variables. Okay, there is no variable. This 4 right here, actually, let's pull this over. We said, let's look at this one. It is nonlinear because it has that exponent of 5. The constant term does not have a variable with it. So between 4 and 3x to the 5th power, that x is your variable, so 4 is going to be our constant. It does not have a variable with it. The constant term is 4. The variable term is the term with the variable. So it's going to be 3x to the 5th power. That would be your variable term, 3x to the 5th power. Now this 3 that's being multiplied by the x, that's called a coefficient. The coefficient of the variable term is 3. That's that number that's being multiplied by the variable, and we call it a coefficient. So there's your quick vocab review and actually the answer to example number 2. Example number 3. How many terms does the expression have? 7x plus 9 plus 6 plus 3x. Again, if our terms are separated by the plus sign, that means we've got 1, 2, 3 pluses, but we got one term out in front of it, 2 term, 3 term, 4 term. Okay, so we've got 4 terms. What are they? We've got 7x, 9, 6, and 3x. Those are our 4 terms. Now, we could rewrite this expression. We could simplify it by combining like terms. What we can do is use the commutative property of addition to rewrite the expression so that the terms that are like are next to each other. It makes combining them a little bit easier. And hopefully you remember that the commutative property of addition tells us that when it comes to adding terms, the order does not matter. So I could rewrite this as 7x plus 3x plus 9 plus 6, and I can group together those like terms to make it easier to combine them. So 7x plus 3x is going to be 10x. 9 plus 6 is going to be 15. So now I've just simplified my linear expression. Now, is this going to be a, I'm sorry, I said linear expression. Okay, well, I just answered the next one. It is a linear expression. Why is it linear? It has an exponent of 1. Let's move on to the next page. Example 4. How many terms does the expression have? Again, remember I told you the terms are separated by the plus signs. I've got 2 plus signs here. So my terms, I'm going to have 3 terms. My terms are 5, 9x times 7, and 2x to the ninth power. So I've got three terms, 5, 9x times 7, and 2x to the ninth power. Is it a linear or nonlinear expression? Hopefully all of you are saying in your head, nonlinear. Why? Exponent of 9 on that x. Now, we can simplify this problem, not because we have like terms, but because we have this 9x times 7. When we have a term that has multiplication in it, we can multiply that out. So we can actually simplify this to 5 plus 63x plus 2x to the ninth power. Again, still three terms. I just combined that 9x and the 7 to give me the 63x. What are my coefficients here? I have two different coefficients. I've got 63 and I've got 2. Now, I cannot combine 63x and 2x to the ninth power because they don't have the same exponent. I can only add these terms together as like terms if they have the same exponent. Example 5. Hopefully you're looking at example 5 and you can answer the questions without me saying a word. Is it linear or nonlinear? 94 plus x 4x to the negative 6 power minus 2. It is nonlinear. Because it has an exponent of negative 6. I could combine the 94 and the negative 2 and rewrite it as 92 plus x plus 4x to the negative 6th. Still nonlinear, still has that negative 6. All right, next one, example 6. Is the expression x to the first power plus 9x minus 4 a linear expression in x? Yes, it is linear. Remember, that exponent of 1, we don't have to write that. That is the same as this 9x over here. So I could actually combine these terms. X plus 9x, that would be 10x minus 4. And that's going to be linear. What powers of x are acceptable in the definition of a linear expression in x? 0 or 1 are the exponents that are acceptable in linear expressions. Okay. I have to go over example 3 with you, or number 3 with you, I should say, because there wasn't an example like this in the examples that they gave us in the lesson. So I want to go over this one real quick. All of this work is kind of combining yesterday's lesson and today's lesson. So I'm going to ask you to do only the evens for class tomorrow. And then we're going to check your work before I give you the assignment for tomorrow. But again, I need to go over number 3 with you. So we are taking the words and we need to write them in a number sentence, and then we need to identify whether they're going to be linear or nonlinear. So if I look at number 3, it says multiply 6 and the reciprocal of the quotient of a number and 7. So what is the thing that we don't know? Remember, we have to define our variable. So x, or we need to assign x to something. We don't know what the number is. So we're going to say x is a number. And let's take a look here. It says multiply 6 and the reciprocal. Remember, the reciprocal is where we flip it. whatever was on top was on the bottom and vice versa, of the quotient of a number and 7. So the quotient of a number, that's the thing we don't know, x over 7, that's the quotient. If we take the reciprocal, it would be 7 over x. So 6 times 7 over x would be what we're writing. 6 times the reciprocal of the quotient of a division, this is division, of a number and 7. You might be tempted to say that this is linear because I don't see any exponents here. However, remember, again, going back to our work in exponents, if we have a variable in the denominator, it could be rewritten as 6 times 7 times x to the negative 1 power. And now all of a sudden we have an exponent that is not 0 or 1. So this is a non-linear. And that is the lesson number 2. Now what I would like you to do is on your owns here on this page, on page 10 and 11, I would like you to do the evens. Have them completed when you come into class tomorrow, along with any questions that you might have about this lesson. Thanks. Bye-bye.